to the Book Doctor channel. Here, we demystify mathematics and make it fun.
In my previous video, we have looked at this question using the formula approach. In this video, we are going to look at this question using the integration factor approach. To use the integration factor, our differential equation should be in the form dy dx plus some function p of x multiplying y is equal to some function q of x. The question is already in the form in which we desire. So comparing, our p of x is equal to minus 4 and our q of x is equal to 3e exponent minus 2s. We shall look for a function known as the integrating factor. Let's represent that function by u. And the function should behave such that its derivative should be equal to the p of x multiplying the function again. In that regard, this function, which we call u, its derivative will be equal to minus 4u. We now solve for this particular function. We divide both sides by u to have 1 over u derivative is equal to minus 4. We integrate both sides with respect to x. Integration of the right will yield ln u, and integration of minus 4 will yield minus 4x. With the integrating factor, we do not need to add the constant of integration, since when we substitute this into our differential equation, the constant can still be absorbed into other constants. So we don't need to worry ourselves about the constant at this stage. We just maintain it in the simplest form. Hence, our u will be equal to e exponent minus 4x. We multiply through by the integration factor. The original equation is y prime minus 4y is equal to 3e exponent minus 2s. So multiplying through by the integrating factor, we'll have e exponent minus 4xy derivative minus 4e exponent minus 4xy is equal to 3e exponent minus 2x multiplying e exponent minus 4s. The left-hand side can be written as a total derivative of the integrating factor and y. So that will be ye exponent minus 4x, or derivative, is equal to, we perform this multiplication, and that is 3e exponent minus 6s. At this stage, we integrate the left-hand side with respect to x and the right-hand side too with respect to x. At the left-hand side, the integral will cancel the derivative, and we shall have ye exponent minus 4x. The right-hand side, the integral will yield 3 on minus 6 e exponent minus 6x plus some integration constant, let's call it a. Let's simplify the expression further. ye exponent minus 4x will be equal to minus half e exponent minus 6x plus some constant a. We'll divide through by the integrating factor, so set that our y will stand alone. So y will be equal to minus half e exponent negative 6x all on e exponent minus 4x, then plus a on e exponent minus 4x. Perform the division, we just subtract the powers of the exponential function. So minus 6x minus negative 4x. This will yield e exponent minus 2x. Then write the exponential function on the same line with the a, applying the rules of indices, and this will be e exponent positive 4x. This becomes the general solution for our differential equation. We'll then use the initial values to look for the particular solution. The initial values given is y of 0 is equal to 2. This implies when x is equal to 0, y is equal to 2. We substitute these values into the general solution. So 2 will be equal to minus half e exponent 0 plus a e exponent 0. This will yield 2 is equal to minus half plus a. Solving for a will be equal to 2 plus half. And a will be equal to 2 whole number 1 over 2, or otherwise 5 on 2. Then we'll write our particular solution, which can be written as y is equal to minus half e exponent minus 2x plus our constant a, which we now know the value, as 5.2, then e exponent 4x. This becomes the particular solution to our differential equation.